Hey again, everybody. This video is meant to help us out with the idea of completing the square here. We learned how to complete the square using diagrams. Diagrams were helpful because they uncovered the algebraic patterns that we can use to complete a perfect square. With our last assignment, people were still using diagrams, which is okay, but we want to start getting more proficient with using our algebraic strategy. So for this one, we're not going to use diagrams. What we're going to do is we're going to rewrite the quadratic function in vertex form in order to identify the location of the function's vertex. And we'll just check our answer in Desmos, make sure that we have the same vertex. All right, so the diagrams helped us see that we can complete a perfect square by taking some of the coefficients here. This is A, this is B, and this is C. We learned that to complete the square, all we have to do is calculate A times B divided by 2A squared. This is basically what told us the number of unit squares when we completed that diagram. It was the number of just the one boxes. All right, so we could just plug in our values into this expression right here and simplify it. A we know is 9. B is negative 36. And then we have 2 times A, so 2 times 9. And we're squaring it. And then it's just some simple math here following our order of operations. Negative 36 divided by 2 times 9. 2 times 9 is 18. So we have negative 36 divided by 18. And we're still squaring it. Negative 36 divided by 18 is negative 2. So we have 9 times negative 2 squared. Negative 2 squared is negative 2 times itself, so that's positive 4. So we have 9 times positive 4, which is equal to 36. So this is the number of unit squares that would complete a perfect square. So what we can do in our expression is add that in instead of 44. 44 was, well, too much squares, would have an excessive amount. We needed only 36. But if we change that to 36, this changes the equation. So, well, we were over by 8, so we'll add 8 back. And now we have two equivalent expressions. But the cool thing here is this is actually a perfect square. However, we can simplify it a bit because all of these are divisible by 9. 9 is the greatest common factor in 9, 36, and 36. So divide each of them by 9, as in factor it out. So we'll have 9 times x squared. 36 divided by 9 is 4. So we have 4x. And again, another 36, so plus 4. And then we still have this plus 8 hanging out here. All right, and this should be a really simple perfect square to think about. We can rewrite that as 9, still right here, times, well, this is just x minus 2 squared. You could set up a little 2 by 2 area model diagram to factor that, but what we're seeing is that it's just this value right here. This is b divided by 2a. That's how I got this negative 2. All we have to do is look back at what we calculated right here. It's what's inside of these parentheses. B divided by 2a was negative 2. We'll always have that right here. And then we still have plus 8. So now we have rewritten Q into vertex form. And we can see what its vertex is. This minus 2 subtracting from the input is going to shift us to the right 2 on the graph. So we'll go over 2 to the right, and then plus 8 to the output shifts up 8. Therefore, we'll have a vertex at positive 2, 8. Yeah, even though this was -2 right here, the vertex will be at +2 because we went to the right 2 when we subtract from the input. Add 8, shift up 8. Therefore, we have a vertex at 2, 8. Well, let's double check to make sure this is true. Should have had Desmos loaded, but I didn't. All right, anyway. Here we go. We had 9, or q of x, was equal to 9 times x minus 2 squared plus 8. There's our graph, and we can find the vertex here. And now we can also check to make sure that we have the same function. The original function was 9x squared minus 36x is 44. And notice that they are, in fact, the same graph. And we have a vertex at 2, 8. So once you get a good picture of this graph, you'll screenshot it. Well, when you screenshot it, have that vertex highlighted. So I'll do that again. And then we'll go back here and we'll paste it into this box where it says insert a screenshot of the graph. And that's it. Hopefully this helps you out. Good luck with the rest of the assignment.